Welcome to solverfy.
Okay, so for the first question, it was asking us what is the value of L if the phase difference is 5.65 radian. Okay, so question A is asking us what is L. Okay, we know K1 minus K2 times L is equal to the phase difference. Okay, K1 and K2 is the different wave numbers. Okay, L is the one we are looking for to figure out. And K, which is the wave number, can be equal to 2 pi over lambda. Okay, lambda is the wavelength. So which means that let's say K1 can be equal to 2 pi over lambda 1. Okay, so K2 can be equal to 2 pi over lambda 2. And the lambda, which is the wavelength, is equal to lambda air divided by the refractive index of different material. So it's lambda is equal to lambda air divided by n. So for lambda 1, which is the wavelength through the glass, is equal to lambda air over n1, the refractive index of the glass. Lambda 2 is equal to lambda air over n2, which is the refractive index of the plastic. Okay, so we'll get that K1 is equal to 2 pi over lambda air over n1. K2 is equal to 2 pi over lambda air over n2. Okay, if we do some arrangement, we'll get that K1, remember from this case K1 minus K2, so K1 minus K2 can be equal to 2 pi n1 minus 2 pi n2 over lambda air. Okay, so K1 minus K2 times L equal to delta phi can be equal to 2 pi n1 minus 2 pi n2 over lambda air times L, which is equal to delta phi. Okay, so if we take 2 pi out, we'll get 2 pi times n1 minus n2 over lambda air times L is equal to the difference of the radians. Okay, so this will give us L is equal to delta phi times lambda air over 2 pi times n1 minus n2. So all I did here is just to simplify the equations in order to get the equation we want, which is the equation that is set to equal to L. Okay, so if we plug in a value, we know the phase difference or the difference of radian is 5.65 radian. Okay, and the wavelength in the air was given as 400 nanometer, which is 400 times 10 to the power of negative 9 meter, because 1 nanometer is equal to 10 to the power of negative 9 meter, over 2 pi times n1 minus n2. n1 from the question was given as 1.60, N2 is 1.50, so 1.60 minus 1.50, okay? And this will give us the value for the L is equal to 3.6 times 10 to the power of -6 meter, okay? So for question B, it was asking us, is it fully constructive or is it fully destructive? Or is it intermediate but closer to the fully constructed, or intermediate but closer to the fully destructive? My answer is intermediate but closer to the fully constructive. Why is that? Well, remember the difference in radian was 5.65 radians, right? If the wave is fully constructive, that means the radian should be 2 pi. Okay, that's for fully constructive. And if the radian is fully destructive, it should be pi. Okay, and the value of a 2 pi radians is about, let me use a red pencil here, it's about 6.28, okay, radians. And the value of pi is about 3.14 radians. And comparing with 5.65, which one is closer? Of course, it's the 6.28 here, okay? It's not, 5.65 radian is not completely constructive because it's not exact at 2 pi, okay? So the answer should be intermediate but closer to fully constructive. Okay, and that's the answer for the question. Thank you.